In our last video for step 18, we were talking about multiplying and dividing rational expressions. And we noticed a lot of the patterns that were present just like when we multiplied and divided fractions. Same thing's going to be true when we try to add and subtract rational expressions. Just like with fractions, we must have common denominators in order to add and subtract them. So how do you find the common denominator? Well, let's think back to how we find a least common multiple. Notice in our first example here, when we're talking about just numbers, just fractions, we can't add 5, 6, and 4/9 unless we give them a common denominator. The common denominator happens to be the least common multiple of 6 and 9. How do we find this? Well, we break them down into their little pieces, and then we make sure that the least common multiple has each factor the greatest number of times it appears. So we need to have 1, 2. And then notice that 9 has 2 factors of 3. 6 only has 1. So we have to have the greatest number of these factors. And when we do that, we get 18. Another way to think about finding the least common multiple between two numbers, start with the greater number. 9 times 1, 9 times 2. 9 times 3, and so on. Checking each one to see if the other number can divide into it evenly. Can't divide into 9, but 18 works. That's another way to get that least common multiple. Then we would have to multiply this by 2 over 2, so that it becomes 8 over 18. We'd have to multiply this by 3 over 3, so that it becomes 15 over 18. And then, and only then, could we add them together because they have a common denominator. The same is true of polynomials. We're going to take each denominator, factor it as much as possible. Then we need to have each factor the greatest number of times it appears. So notice we have a factor of 2 from the second denominator. We pick up a factor of x minus 1 from the second denominator. We pick up a factor of x minus 2 from the first denominator. And finally, a factor of x plus 1 from the second denominator. You might say, well, what about this one? Well, he's already on the list because he only appears once in either denominator. So we only need one factor of x minus 1. Let's practice it with a few more examples. Let's break 6xy into its prime factorization. That would be 2 times 3 times x times y. 15 would break down to 3 times 5, and x squared is x times x. 9xy to the fourth would be 3 times 3 times x, followed by 4 factors of y. So when we want to make a list of our least common multiple, we need a factor of 2. Comes right from there. This one has one factor of 3, one factor of 3, 2 factors of 3. So we have to choose 2 factors of 3. That takes care of our 3's. And then we have one factor of 5. Now let's take a look at the x's. 1x, 2x, 1x. The greatest number is 2 x's. That takes care of the x terms. Next, we need to look at the y's. This one has 1 y, no y's, 4 y's. 4 y's, 4 factors of y wins. And then we simplify. 9 is 3 squared times 5 is 45 times 2 makes 90. And then x squared, y to the fourth. Again, another way to think about the coefficients here, we could have started with 15. 15 times 1 is not divisible by 6 or 9. Times 2, it's divisible by 6, but not 9. Times 3, it's divisible by 9, but not 6. Times 4, it's divisible by 6, but not 9. And so on. until we arrive at 90. That's the first number that's divisible by 6 and 9. All right, let's take a look at this one. First, we always check for a greatest common factor. They all have a greatest common factor of y squared. So I'm going to factor that out first. And I end up with y squared plus 8y plus 15. If I were to distribute this, I would get back to exactly what I started with. I can take this further though. Y squared, that trinomial can break apart into two binomials. What numbers multiply to give me 15 and combine to give me 8? That's right, 3 and 5. Now I have it broken down as far as I can go. This one starts out a trinomial. There's nothing common, so I'm going to try to factor it. What multiplies to give me negative 40 and combines to give me negative 3? 1 and negative 40, 2 and negative 20, 3 doesn't work, 4 and negative 10, 5 and negative 8. We have a winner. 5 and negative 8 gives me negative 3. So that's my winning combination. Now we need the least common factor, least common multiple rather. I have two factors of y, so y squared. I only have one factor of y plus 3 between the two. I need one factor of y plus 5 because they each have one factor. That takes care of this. I already have that factor. Oh, and now we also have to pick up a factor of y minus 8. And it's perfectly fine to leave your least common multiple in factored form. Let's apply this. All this is saying here in this key concept is you must have a common denominator to add or subtract rational expressions. That's all of this in a nutshell. So the first one, we have 2x and 5x. Let's come up with the least common multiple. This is a factor of 2 times a factor of x. This is a factor of 5 times a factor of x. So my least common multiple needs a factor of 2, a factor of 5, and then they each have one x. X never appears more than once. So my least common multiple is 10x. So next I need to look at this and think, what could I multiply each one by so that it becomes 10x? So I have 3y over 2x. What would I need to multiply it by to make it 10x? Well, I need to multiply it by 5. And if I multiply by 5 on the bottom, that's right, we multiply by 5 on the top. Looking at this second rational expression, 2z over 5x. What do I need to do to 5x to turn it into 10x? That's right, I need to multiply it by 2, and if I do that on the bottom, I also do that on the top. 5 times 3y makes 15y over 10x. 2 times 2z makes 4z over 10x. Now they have a common denominator, so we just write that common denominator in our answer, and we add the numerators. And that's our answer. 7y and 3y. What would be the LCM? That's right, 21y. So I need to multiply this fraction by something and this fraction by something to turn it into 21y. The first fraction needs a 3. 3 times 7 would make 21y. The second fraction would need a 7. When I multiply those, I get 18 over 21y, subtract 14c over 21y. Again, when we're adding or subtracting, we keep that common denominator. Once you find the denominator, you're done with the denominator. That's the denominator of your answer. And then I'll have 18 minus 4c. This next one's a little more complicated because now our denominators are trinomials. So when we want to figure out what they break down to as factors, we need to factor them first. What numbers multiply to give me 3 and combine to give me -4? -1 and -3. Remember, like when we simplified, if you've changed that to its factored form, get rid of it so you don't get confused. This replaces it. And over here, what multiplies to give me -6 and combines to give me 5? Remember, 6s and 5s can get tricky. Let's think about this. -6 could be -1 and 6, -2 and 3. This combination gives me 5, -1 and 6. Put a line through that because we factored it. Okay, so my answer must have one factor of x minus 1, because they both have one of those. It has to have a factor of x minus 3, and it has to have a factor of x plus 6. So if we look at the first expression, just the one here on the left, x minus 1, x minus 3, x minus 1, x minus 3, it needs x plus 6. So we need to have a factor of x plus 6. Now, 1, 2, 3, it has all 3 common factors. The second rational expression, it has x minus 1, it has x plus 6, but it's missing the x minus 3. So if I go ahead and put it there, that's fine, but I have to do that on the top as well. Now we need to simplify it a little bit. Right here we have 4 times x, 4 times 6. That gives me 4x plus 24. In the second rational expression, x times x times -3. That gives me plus x squared minus 3x. So we're looking really good, except we could probably polish this up a little bit more. Here's our common denominator. The numerator, we have an x squared, putting it in standard form. 4x minus 3x gives me just x. And then finally, plus 24. That's my final answer. Go ahead and pause your video and try this next one. See if you get the same answer. Hopefully you ended up with a plus 3, a plus 4, a plus 5 is our common denominator. Notice the first fraction needed a factor of a plus 5. The second fraction needed a factor of a plus 3. And one thing that's very tricky on this one, we're subtracting. That's why I simply wrote the numerator of the first expression minus the numerator of the second expression. You need to be really careful that you distribute the entire -3. Otherwise, you'll end up with the wrong sign. All right, let's practice simplifying when we have a complex fraction. The trick is going to be to just multiply by the least common denominator, or the LCM. So notice in our first expression, we have a factor of x, and in the second expression, we have a factor of y. So I'm going to just multiply by xy over xy. You find the least common multiple and you multiply by it. In the numerator, xy times 1 is just xy. Xy times 1 over x, that gets a little tricky. Let's go ahead and write it out. Xy times 1 over x. Make them both a fraction. Do you see how the x's cancel? And I'm left with just y. In the denominator, xy times 1, and then xy times negative x over y. Again, now the y's cancel. X times negative x is negative x squared. And that's my answer. I don't have to simplify it any further. Let's try this one together. See, we have a factor of c. We have a factor of d. So we want to multiply by both of those. Multiply the numerator and the denominator by that least common multiple. And when I do that, CD times C over D, again, it's okay to write it out so that you can see how they cancel. Gives me just C squared. Then we have CD times negative D over C. The C's cancel. I'm left with negative D squared. In the denominator, CD times D over C. The C's cancel. I'm left with D squared. And CD times 2 is simply 2CD. The big advantage of being able to add and subtract and multiply and divide rational expressions, why we've been practicing this so far in all of our videos, is so that we can ultimately solve a rational equation. When we're trying to solve a rational equation, the first thing we want to do is multiply the entire equation by the least common denominator. So off to the side, let's figure out what that's going to be. In my first denominator, I have a factor of x plus 3. In my second denominator, I have a factor of 6. And in my third denominator over here, I have a factor of 18. Well, let's think about this for the numbers. So there's our first denominator, second, and third. This doesn't factor, it's just x plus 3. This could be 2 times 3. And 18 could be 2 times 3 times 3. So my least common multiple, or my least common denominator, is going to need that factor of x plus 3. I'm going to need one factor of 2, and I need 2 factors of 3. So my least common multiple ends up being 18 times quantity x plus 3. Now again, another way to think about that, start off with 18. Write the multiples. And you can stop when you come up with one that's divisible by 6. That's the least common multiple for the coefficient. So let's multiply the entire equation by this least common multiple. I'm going to do that times the first fraction. Then I'm going to multiply it by the second fraction. And I'm going to multiply it by the third fraction as well. But before I actually multiply anything, we want to simplify. each piece. I have 3 pieces. In the first piece, the x plus 3's cancel, and all I have is 18 times 4, which gives me 72. In the next expression here, the 18 and the 6 cancel. When I multiply these two coefficients, 3 times 5 gives me 15, x plus 3. And on the right side of the equation, the 18's cancel, and I'm left with 23 times x plus 3. Already, this equation looks much more simple than what we started with because we don't have fractions anymore. This kind of takes us back to Algebra 1 when all we have to do is distribute and combine like terms. So we have 72 plus 15x plus 45 equals 23x plus 69. And then we continue to solve. I'm going to subtract 15x from both sides. On this side, 72 and 45 can combine together. And when I do that, I get 117. Right here, I have 8x plus 69. Subtracting 69 from both sides, I now have 48 equals 8x. Dividing by 8, x equals 6. And if we plug this back into our original problem, 4 over 6 plus 3 plus 5 over 6, does that equal 23 over 18? Well, this would be 4 over 9 plus 5 over 6. I need to have a common denominator, so I'll make that an 18, I'll make that a 15, I'll make that an 18, I'll make that an 8. You could just use your calculator though, that would be fine as well, but 8 plus 15 is 23. So yes, this is our solution. It's really important to check your solution every time because when you're solving rational equations, you can pick up extraneous solutions. Let's try this next one, see what happens. First, I need to know what each denominator would factor into. I see a trinomial, which ends up being x plus 5 and x plus 3. This denominator is already factored and this one is already factored. Notice that my least common multiple must be x plus 5 times x plus 3 because every single denominator has at least one x plus 5 and at least one x plus 3. All right, so we need to multiply this entire expression by this common denominator. X plus 5, x plus 3 times 2x over x plus 5 minus x plus 5 times x plus 3 times x squared minus 10 over x plus 5 times x plus 3 equals x plus 5 times x plus 3. Now this is looking pretty horrendous, but once we start to multiply and cancel things out, it will simplify rather quickly. All right, and the first rational expression that we have here, our first term, if you will, the x plus 5's cancel, and when I multiply what's left, 2x times x gives me 2x squared, 2x times 3 gives me 6x. In the next term, x plus 5's cancel, x minus 3's cancel. I simply have subtract all of these terms. I'm going to go ahead and just write it like this. just to make sure we don't mess up our signs. Subtract the entire second piece. And over here, the x plus 3's cancel. And when I distribute, I have 3x plus 15. Now I'm going to distribute this negative throughout the parentheses. 2x squared plus 6x minus x squared, positive x, positive 10, equals 3x plus 15. Combining our like terms, we're left with x squared plus 7x plus 10 equals 3x plus 15. I'm going to move both of these terms to the other side by subtracting 3x. And in the same step, I'm going to subtract 15. Now I have x squared plus 4x minus 5. When I factor this, I'm thinking, what multiplies to give me negative 5 and combines to give me 4? That would be positive 5 and negative 1. To solve this quadratic, we need to set each piece equal to 0. X minus 1 equals 0, or x plus 5 equals 0. I add 1 to both sides to solve. I subtract 5 from both sides to solve. Next, I need to check both of these potential solutions to see if one of them is extraneous. To save myself a little bit of time, I'm going to use the calculator to check it. First, I'm going to store the first answer that I had, which was x equals 1. 1 stored for x. Enter. Next, I'm going to just type the left side of this expression just how I see it. In fact, let me zoom in a little bit so we can read it better. I have a fraction, so alpha y equals 2x over x plus 5. Subtract another fraction, alpha y equals x squared, subtract x, subtract 10. In the denominator, x squared plus 8x plus 15. What do I get for an answer? 3/4. Now I need to type the right side of my equation in. And I hope I get 3/4. If not, it's an extraneous solution. 3 over x plus 3. 3/4. So that means that our first solution works. X minus 1 is a solution. Now we need to check negative 5. I'm going to type negative 5, store x, enter. Now that was great fun to type all of this earlier, but I don't want to do it again. It's the same thing, so I'm going to press second enter, second enter, second enter, until I see it appear, and then I'll hit enter. And it says, error, you're trying to divide by 0. If we look at it closer, bring this back into our view here. If I make x equal negative 5, this denominator is 0, and that's never allowed. So this solution is extraneous.